Hey everybody, Lars here. Gonna hop in tonight. Hopefully gonna make it a quick one. And really quick, show you how to take some of the stuff we learned in Unit 2 and solve a real problem. First, I'm gonna tell you a little story, show you Project Euler, and then we're gonna go solve problem number 6 from Project Euler. First thing I want to do though, before I tell you the story, is check out this movie. It's called 0 Days. I think it's on Showtime. I got it off of Amazon though. It is about a thing called the Stuxnet virus, which was a joint project between the U.S. and Israel to attack a uranium enrichment plant in Iran. It is absolutely fascinating. You can see there it got 91% at a whatchamacallit, Rotten Tomatoes. So I saw it last night. It was very good, very computery. Talks about cyber weapons, things like that. Thought it was a good movie. Wanted to recommend it to you guys. I usually start out this video by telling a story. Back in 2010, I built the Cave, which is the collaborative lab for the computer science department. The undergrads basically use it as their headquarters, and it's basically where all the computer science kids at Rutgers hang out. So back in 2010, 2011, there were not Python classes at Rutgers University. You are now taking a Python class because I'm teaching it, but back in the day, there were no Python classes. So we would have students walk into our lab and say, hey, I want to learn Python. What should I do? So what me and my iLab assistants used to tell them is go to, and you're going to see it right here, Learn Python the Hard Way. It's one of the resources you're going to be doing for your midterm project. And follow the steps in Learn Python the Hard Way. You go through those 50 chapters. You don't have to do all 50 of them. And slowly but surely build up your Python skills. They make you type all the code in. That way you make mistakes, and correcting mistakes is a big part of learning programming. And then when they're finished with Learn Python the Hard Way, they said, now what should I do? And we would send them to Project Euler. You can see up here, Project Euler. It's pronounced Euler, not Euler. Looks like Euler. I used to always say Euler. I was corrected in a big math class in front of everybody, and it was very embarrassing. It's Euler, okay? ProjectEuler.net, and then it brings you to the About page. And what Euler is about is number problems. You see there are 579 currently number problems. And what you do is you can use programming languages, Java, C, C++, Python, to solve these problems. And then if you register, and I'm going to show you, I set up an account for the class. So if you want later, you can sign in. And actually, I'm going to let me go sign us in. No, I don't want to log in as myself. We are going to log in as PMDS. That's Python Methodologies for Data Science for you. S for Spring 2017. And the password is all lowercase, Python class, PYTHONCLASS. Then I'm going to put in the confirmation code to prove that I am not a bot. And when I hit sign in, I hope to have luck. Look at that, sign in successful. And you can see here it says logged in as PMDS S 2017. So we have solved no problem. So if I look at progress, we will see that I haven't solved anything. It's all blank. But that's going to change in about 15 minutes. So you go to Project Euler and you read about Euler, famous mathematician, blah, blah, blah. And here are all the number problems. So we used to tell our kids, go do Learn Python the Hard Way, and then go to Project Euler and do about the first 50 problems, because the first 50 problems, I believe, and later we'll check this out, if you go to statistics and you look at who's done what problems, back in the day, if you did the top 50 problems, it would put you in the top 5%. That's not the case anymore. Puts you in the top 6%, but you can see that says 5.927. So back in the day, 50 problems would make you 5%er. That's what we called it. And if you could solve the first 50 problems with Python, you knew Python pretty well. Because a lot of the things that we've done so far, using lists, iteration, things along those lines, are the kind of skills that you use when you solve these number problems, okay? But I'm getting ahead of myself. So anyway, we used to tell people to go to Project Euler. Everybody used Project Euler a lot. So a couple of years back, I ran a seminar called Project Euler. We talked about problem solving and from a cognitive psychology standpoint and some other things. And a popular part of the class was we used to practice computer science interview questions. There's a book called Cracking the Code with a bunch of famous problems. And all of a sudden now the kids took it over and actually made a university club out of it. For a couple of years, they called it just Euler after the seminar, but now they call it CMIC. They call it Computers, Math, and Interview Questions, and then something else with the C at the end of the day. But there's actually a university club now that was built around solving these problems, and then it morphed into solving interview problems. So I always figured that's a good story. We are going to take some of the skills that we have learned thus far in Unit 2 and Unit 1, and we are going to tackle, let's see, archives, problem 6. Now, I'm going to right from the beginning tell you what we're doing here is not the best thing in the world to do, because you're not supposed to publicize solutions for Euler problems. Because think about it. What if somebody else wants to come here and try this problem, and all of a sudden I'm solving it and putting it up on YouTube? And you really shouldn't do that. And believe me, I know when you start doing the problems, you can look at Stack Overflow, and if you Google them, you can find all the answers. That's not the point. You want to do the questions to learn and build your Python skills and do all that stuff. So technically, what I'm doing here isn't the best thing in the world. That said, look at the problem. It's not the hardest problem in the world, okay? People aren't falling over unable to solve this problem. As a matter of fact, when we solve it, we'll see how many people have solved it. And you'll see that there are thousands. This is an easy one. So I figure for the sake of our Python class, once again, I'm going to ruin problem number 6 for the world, but that's okay. All right? So let's take a look at it. Sum square difference, problem 6. The sum of the squares of the first 10 natural numbers is blah, 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 385. Okay? Then flip it around. The square of the sum of the first 10 natural numbers is blip, 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 blip. Then square it. 3025. 55 squared. Okay? So 3025, you'll see here, hence the difference between them is 3025 minus 385, 2640. Okay? So that's how you do for the numbers from 1 to 10. But down here it says find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. So instead of just doing it for 10, you want to do it for 100. Well, if I'm a Python programmer, I kind of know how I can do that. Because let's see, I already have a worked example here. Why don't I code up that worked example and see if it works? And if it does work, well, then I can go change my 10 to 100 and just rerun it and solve the problem for this. So let's go do some code. I fired up idle right here. I'm going to go get a new file. And I'm going to save it. It's going to be up in your Sakai. Eventually, I'm going to save as, where is my Python for data science? Spring 2000, Unit 2, and I want to call it E6. I will just save that, yes, but I will replace it. All right, good. So we're ready to rock and roll. I will just say author Lars, and I'll just say Euler 6. All right, save. All right, so I'm in good shape. So I'm going to teach you a little trick right here. A lot of times if you know what the question is, or you know what you want to do, just highlight it, copy it, 1, 2, 3, space, paste, boom. Well, that doesn't look very good. That doesn't look good at all. How did I go back there? There we go. All right, good enough. Now, look at that. We actually have the definition of the problem up here. So we don't have to worry about running back and forth to go look at what we're looking for and boom, 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 boom. We can actually take the text from here and put it right up here. All right, so we're in good shape. What's the first thing we want to do? We want to find the sum of the squares. So what do? For I in range, I want to start at 1 because I don't want 0, and I want to go to 11 because I don't want to go, I want to go to 10. So I do that And what am I trying to find? The sum of the squares. So I want the sum of the squares. Let's do this. I'll create a variable called SOQ square equals 0. And then what I'll do here is I'll go SOSQ equals, just like we did with our accumulator, plus, but I want the squares, so I'll do I squared. Nice. All right. So now print sum of square. Let's see what we got. 385. I think we're in Fat City because look, that kind of works right up there. Okay. All right. So we got the first one. Now, what do we do for the second one? First of all, let's save ourselves a little bit of time. Cut. A paste. Now we doubled it up. Only this time I want the square of the sum. So I'm going to change that around. I'm going to change this around. What do I want to do? All right. Square sum, not Q. And oh, I'm running out. I'm on a diet, yeah, because I'm a chunky monkey. So I'm trying to shave off the calories, right? Well, there's two things. Basically, the only two things I have to enjoy in my life now are these crappy little 15-calorie popsicles. And about a month ago, I found Sprite Zero. Sprite Zero has 0 calories, but it tastes good and it's sweet. And I'm thinking it's a secret that nobody knows about. It tastes like regular soda. All of a sudden, I have a phone call with my sister today, and she starts telling me that it's full of aspartame, and I'm going to get headaches, and it's going to give me cancer. And I have no, I don't, you know what? I'll have cancer. Cancer is a small price to pay for Sprite Zero because it's tasty and it's no calories. You won't get fat on it. And I don't get any headaches or anything. But aspartame's not good. It kills rats, doesn't it? I don't know. That's not a very scientific thing to say. But I'm drinking the last of my Sprite Zero, and it's annoying me. I probably will end up getting a headache now because I'm thinking about it too much. All right, I digress. Square of the sum equals 0 for I in range 1 to 11. Square of the sum equals square of sum. Only this time, I just want to add it because what I want to do is get that final result, and then I want to say square of sum equals square of sum squared. And then I'll square it at the end. So I'll add it all up, and when I have it all added up and I get my, 55? Or yeah, that should be, actually, that should look like, where's my caret? That should look like that, so because it's 55 squared. When I get my 55, I want to square it then, okay? And then I'll just print it down here so I know I'm good. Comma, square sum. Am I? I am. 3025, just like up here, 3025, okay? So now, I mean, this is a piece of cake, right? I want to print the difference is, and then it's what? Square of the sum minus sum of square, right? So I run it, and it says the difference is 2640. Well, look at that, 2640, okay? So I got a little piece of code here that I think is doing what I want. I never did this. The square of the sum. Nice. And then print the differences. Boom, boom, boom. Okay. So there's a little piece of code that seems to be following the logic of that up there. But wait, I'm not done. Find the difference between the sum of the squares of the first 100 natural numbers. Okay. So let's take that 11, make it 101. Let's take that one, make it 101. Okay? And now when we rerun it, we're doing 100. Oof. And we get a much bigger, kookier, crazier number. But that's the number we get. The difference is that. So we can go back, and we will in a second, and see if that's right. But I think me being a nerd, I'm going to have to change up this program a little bit. When I use range, if I'd like, I can use variables. So what I think I'm going to do, instead of using those hard numbers, is I'm going to create a variable called limit, and I'm going to make it equal to 100. Because let's say I want to do 1 to 100. I'll do my limit to 100. So I will do limit here and limit here. Well, what's wrong? that pregnant pause again. If I use limit, I only go to 100. This is the second part of a range, so it should be the first thing I don't want. Okay, so if we ran this, it would go from 1 to 99. I don't know if I really want to do that. So I can just fix that by adding a +1 to the end of the variable. And that'll work fine. That'll bounce me right back up. That way I can keep my limit readable so that it's 100. And we'll rerun for 10 right now. And then I'll just add the 1 to make the second part of the interval exclusive. So now when I rerun this code, I get 2640. So I'm back to my 2640 here. That tells me my code's working. So now I just have to take limit, rerun it again, and boom, I get that. So now that's a little bit better way of doing it in my mind. I really only have to change the variable in one place in order to get the result and to get that logic to work for different numbers. Again, if I wanted to, I could rewrite it and take input from the user and do the limit variable that way. I'm not going to go that far right now. We're just going to go see if this works the way we have it written up right here, okay? So this is our answer, okay? This is the difference between the sum of the squares and the square of the sums for 1 to 100. Now, this is neat. You're going to like this. Well, first of all, I'm just going to copy and paste that. And then we are going to go to Euler. And we're going to go to the problem, and I'm going to paste the answer in there. And I'm going to put in the confirmation code, 590. Is that a 0? And we're going to hit check. Get ready. It's taking a long time. Look at that. Haha. If you get it correct, you get a green check mark. Okay? And as I always tell people, getting that green check mark is a buzz. I don't care who you are or how many problems you solved. It's always neat to see that green check mark. And look at this. This is the 344,268th person to have solved this problem. So quite a few people have tackled Euler 6, okay? But now, if we go to progress, we've done number 6, okay? It's done, and we see how many people have done it. The difficulty rating is 5%, so it's not very high. But as you can see, once you solve 25, you're level 2 and level 3 and level 4. I mean, it's pretty neat stuff. And then you come to statistics, and you can go to problems and see how many people have done one problem. It's quite a few. Most people come in here, solve 1 or 2, and then they get out and leave. But if you solve, let's see, 32 of them, you're already in the top 10%. So stick with it. Solve some problems. Okay? You can always go back to archives, find another one. That might be familiar to you if you look at it. Yes. The first one. Palindromes, prime factors, prime numbers have a lot to do with these problems. These problems are a lot of number theory problems if you read them and you check them out. A lot of things to do with primes, Mercian primes, different kinds of prime numbers, different kind of number theory things. Okay, so feel free to log in and solve things if you want. You could log in as the class PMDS-S2017, and the password is Python class, all in lowercase, PYTHONCLASS. Okay, I guess I'm going to sign out. Actually, no, let's go back to the question. If you go back now, after you've solved it, you can see the answer is there. See? And you can see the day that you solved the problem. So you're never going to have to solve that again, at least not when you're logged in as this. And if you go down the list, you can see you get a check mark and people talk about it and do some different stuff there. Okay? All right, so I'm going to sign out. So that is how you can now use what we've learned in the first 2 units to start attacking problems. You can definitely go to Euler and find other problems that you can attack with these skills. That's what we're talking about. We have a lot of stuff in our toolbox now. We have lists, we have iteration, we have all kinds of different if-then, we have different ways to go about solving problems and taking what we know about programming and creating logic in order to solve these problems, okay? I'm going to take this and I'm going to throw it on the Sakai site, and you guys can take it and play with it and do whatever you want, okay? All right. Announcements. You have all your resources. You have both assignments. You have your readings. You have your slides. You have your 2 review videos. So you should be set to polish up the assignments and study for the quiz, which will happen Thursday. Thursday is the last day of the unit. A word of warning. I do want posts for the forum to be up 3 days before the unit ends. So Monday is going to be drop dead for that. If you do a post after Monday, it's going to be 4 points, not 5 points. And those points add up, so get points where you can, okay? I want those forum posts to hit early so people can read them and comment on them if they want. And it's just a good way to space out the work during the thing. So drop dead for those forum posts is Monday. You won't get full marks if you put them in on Tuesday or Wednesday, okay? Do the forum post 3 days before the end of the unit. All right? Other than that, everyone's doing great. Go check out the info sheet for the midterm project. You've got a month to do it. I think the due date is March 12th, so it's like almost exactly a month from tonight. I'm filming this on February 11th. And you should be fine. All right? It's actually fun. Learn Python the hard way is easy. Code Academy is easy. Watching the MIT videos is easy. And then I want you to do a compare and contrast of what you thought, what you enjoyed the most, what you thought was the most useful for you as a learner, and things along those lines, all right? All right, then I'm going to get out of here. Go watch that movie on the Stuxnet virus, 0 Days. It's very good, very, very good. And I will be in touch, as you know. I am rather verbose with the announcements. So I'll be doing announcements every couple days, keeping you informed, keeping you up the track. And then Friday, is scary Unit 3 that I've been scaring everybody about. It's actually fun, and you'll see when we get there, all right? So keep up the good work, keep chugging along, and you're going to be fine. Everything's going to be good, all right? You have a good night. I'll talk to you later.